in the cloud computing computation. Because here, if you are a small company, you have a lot of disadvantage. You cannot do a lot of things as I explained. And if you only have 1,000 servers, right, you cannot accommodate big customers. And big customers are where you have the most profit margin. Yeah, it's a profit margin. Okay, now using the following roughly 25 minutes, let's move into the data centers. Okay, first is that for data center is a building with thousands or even over 1 million of servers. The first question you may have is that why not using a single machine? Actually, this is what Twitter tried from the beginning. So they don't want to have the problems or the challenges using a distributed system. Right? Therefore, they try to put everything just on a single server. But they keep upgraded, right, to get the most powerful machine. But over time, when they don't have enough capacity on their single machine, you will say that Twitter is over capacity. So this is actually the traditional approach, right, in supercomputer. Right? They are basically doing this. They try to build a very large, but it's a single machine you can consider, right? Because it's managed very closely, right? For even they have multiple server racks. Right. So for the user, you can program like it's a single machine. Right. But later, they just don't have enough capacity for the data and not enough I/O bandwidth, right, for the networking, and not enough computing capability. Then they are eventually forced to make it a distributed system. Right. Because you can imagine, for the same amount of computing resources or the bandwidth or the storage of memory, right? If you want to put it on a single server versus I can make it on many just commercial level, the consumer grade servers, then the cost can be much lower. In some cases, even 100 times difference. Right. For example, if you just buy the memory for 32 gigabytes, right, so that is a very common you can get. But if you want to do like a 1 terabyte memory or 32 terabyte memory, right, for a single server, it is very hard. Even if you can get one, the price can be very expensive. Right. So from this one, you can also say that Twitter is not a very classic IT or technical company, right? Because when they face the technical challenge, their solution is try to delay it as much as possible, right? Versus like Google, so even for some problems they can delay, they try to just finish it, fix it as early as possible. Or sometimes they are just too early. Right? I think Google Glasses is one product that probably just too early. Okay, but be careful right? When you see an IT company, they claim the IT company, but actually they don't want to solve their technical problems, right? So you say the stock price for Twitter is not similar like other IT companies during the past 10 years, right? I think, of course, there are many other reasons, but this can be one reason. As an IT company, they don't want to focus on tackling the IT challenges. So, okay, now let's talk about we need to make a data center of many machines, right? So what's in a machine? In a machine, you just want to connect. You need something to hold the data, right? That is a memory, or you can put it on the disk. And you need something to process the data, and that is your processing unit. That is often the central processing unit, the CPU, or it can be the graphic or other accelerators nowadays. Right? Note that the difference between the memory and the disk is that the processors can only access data in the memory instead of disk. Therefore, if you have disks, the data need to be first put into the memory, then going into the processors. Okay, with the storage, with the processor, and with the interconnect between them, you can already have a server, a machine. But you want to also put the data onto the machine, or get data out of the machine. Traditionally, you can use some flash drive to do that, right? But nowadays, most of them are through the network. Ethernet is what we mostly use. Of course, you can use Wi-Fi, you can use other connections, right? So the networking allowed one machine to talk to other machines. This is the speed, because eventually you have the data and you want to move the data around. In the old days, people consider the processing unit, the CPU, as a center of the computer. Right. That's why you see company like Intel dominates the progress of a computer during the past half century. Right? They dominate the processors. Right? But more and more, now we see that what actually should be in the center is the data. Right? Because everything involved in data. But the data, the problem is not only the interaction with CPUs. There are also GPUs, other accelerators, and you need to store the data, and you need to move the data. Right? The processing is only one stage in the data processing, instead of the main stage. In the old days, processing is the main stage, but now it changed. Data is in the center. So here, between the memory and the CPU, the speed can be fairly high. That can be like 100 gigabytes per second. But if you use SSD, that is much slower. If you go to the traditional hard drive, that is even slower. On the other hand, actually moving through the Ethernet, that can actually be fairly even higher than a local disk. Right. There are also other high-speed connection like the Ethernet band that increasingly used for GPU servers, because there for distributed machine learning, we need to share data frequently, and that becomes a new bottleneck compared to the local processing. Actually, even for your local computer, the personal laptops, you can also see the trend. 10 years ago, it is more often that you see the CPU is a bottleneck. If you run some game, run some other applications, or you open a lot of browsers, you don't have enough CPU capacity to support that. Then something is delayed, and sometimes the system may even tell you it's busy, you need to wait a little bit. But that is less and less frequent. So this is probably partially due to we have multi-core systems. In the old days, we only have a single core. And if that core is busy, then we have a problem. But now, even on a laptop, you may have 8 cores or even more. With 8 cores, as long as one of them is available, then they can process it. So that is a big progress. Of course, each core is not as powerful as previously. The frequency is lower, but there are not so many computations we need to do. As we say, a lot of computations actually go into the cloud by the software as a service. If I open a lot of Office applications locally, I'm consuming my local resources. So that may have a pressure on CPUs. But if I'm using Google Doc or the Office 365 online, then I'm doing the processing remotely in the cloud, but the new bottleneck is the internet. So now, more and more, you can see the problem is the internet. So it's a network is busy. So you cannot run many applications in parallel. So now what's more important probably is not to buy the most powerful server or laptops. Instead, you want to have a better network connection. If your local connection is 100 megabytes versus others, they have a gigabyte network. So you will say, even your computer is more powerful in using the internet many SaaS applications, your experience may be worse than the other, because network now, many cases can be the new bottleneck. Okay, of course, here we didn't include many others, but this is a simplified machine structure. In the old days, as I described, what we want to do is make the machines more and more powerful. This is called scale up. So as the figure shows, this is the number of transistors in CPU. The transistor is basically you can consider to use to do the processing. Okay, you can see it's look like a fairly linear, right? But it's a log scale. The x-axis is linear, while the y-axis is a log, which means we have the exponential progress increase in the number of transistors in CPUs. Right. So this is summarized in Moore's law, stated by the Intel founder Gordon Moore.